We now have Chris DiMartini talking with us about how to build network graphs in Tableau. It's kind of pushing the boundaries of what Tableau can do, and I'm very interested to hear what Chris has to tell us about. So Chris, without further ado, take it away.
Thanks, Emily. Hey everyone, how's it going today? My name, as she mentioned, is Chris DiMartini, and I am currently a director in internal audit at Visa. In that role, I lead the data analytics program for Visa, or for the internal audit department of Visa. And I'm really responsible at the end of the day for the direction and implementation across the analytics across the department. In addition to my role at Visa, I also do some work with Datablick as well, and can be found on their Help Me Datablick service. And I also guest blog on Datablick from time to time. Before we get started, I just wanted to say a big thank you to Jen and Emily for putting this on. I think this is fabulous, and I'm really glad to be part of it today. So without further ado, let's jump into it. And can you see it, Emily?
Yes, I can.
Great. Okay, so like Emily mentioned, I'm going to be talking about network graphing in Tableau today. We're going to be talking about some methods that you can use to push the boundaries of Tableau as you know it. I don't think these are the actual boundaries of Tableau though, because I haven't really found those yet. I'm going beyond the Show Me tab, and I'm going to bring you some graph types that you've not thought of as native to Tableau, but rather reserved for other tools like D3.js and other things like that. To that I say, why not Tableau? To borrow a phrase from a recent Think Data Thursday presentation, Jeff Schaefer, Noah Salvatierra, and I did, everything is Tableauable. To start us off, I built a bit of a teaser in Tableau, which I'm going to show you here. And, sorry. So what you're looking at here is our slogan from our beloved French festival, from the community for the community. And what you're actually seeing is the word community as viz. And this is made up of Bezier curves. There's about 16 to 18 Bezier curves that make up the, I guess you could call it a font that defines the words that you see here. And as I mouse over these, you can see the different coordinates and everything that was needed in order to build these words. And there's one difference between the word on the top and the word on the bottom. Take a second and see if you can figure out what that is. One of the things I wanted to start off with is the way I go about structuring the underlying data for the visualizations that we're going to see today. And so that's what you see here. And so with the visualizations that we go through, you're going to have this common theme of a path field, which you can see here with the value C1 in it, a start and stop of that path, and associated values and calculations and things like that. And so one of the key things that you'll notice is that for each one of my records, I actually have two records, one for the start point and one for the stop point of the path. And what I wanted to do was leverage this structure as much as I could. So actually everything that you're going to see in my presentation today all boils back down to this one set of data. Well, not this one set of data, but this one structure of data that I'm showing you here. What I want to start doing now is talk about one of the key concepts that I use against this set of data. So it's referred to as data densification. And what we're talking about there really is the ability to take this path that has two records and make it 101 records. And that's one thing that's required for some of the curves that we're going to be building today. So just to give you an example of that, I'm going to start manipulating this data in Tableau here. And you'll see, for example, as I remove the path order field and I go ahead and do show missing values, you'll see that for each one of these records now, I went from having 2 data records to 101 data records, from 0 to 100. You can also see that as I scroll down these records that the curve X and curve Y values are now null across the majority of those. I'm going to talk to that in a second. One of the other examples that I'm going to provide with this is this view here. In this view, really I'm just trying to showcase the importance of using window table calculations if you are going to do data densification. Data densification isn't the only technique that you can use to do something like this. There was a couple good examples that Noah Salvatierra and Jeff Schaefer talked about during that Think Data Thursday that I already mentioned. But the one that I end up going back to for the most part is densification. And I learned most of what I've picked up on that from Noah's 3D blog post. So definitely take a look at that if you're interested in these techniques or want to take a look at densification further. So just to continue to highlight some of the things that you'll need to do when using data densification is if I go ahead and flip this to show missing values again, like I did on the data picture, you're going to see the top record, which is just the standard number of records calculated field that Tableau provides whenever you join to a data source, has a value in record 0 and a value in record 100. And that ties back to what you would see here if I turned off show missing values. And so as I'm looking at the top record here, you can see that I only have 2 out of 101 values. On the bottom, what I've done is created a window table calculation against that densified field. And starting from 0 and going to 100, I now have all 101 values populated. And so just to give you an example of what that calculation looks like, pull that up. And so what I'm talking about here is having a window sum on the sum number of records. And for the most part, with window table calculations that I'm going to talk about today, the aggregation doesn't actually make a difference because we're going to just be carrying the value across the densified data. And so the key thing for me really is more of these operators at the end where you're calling either the first or the last record of the data. So I'll talk to those a little bit further. Here's some examples that I've mentioned, just like the one I just showed you. Here you can see I'm using the min operator instead of the sum operator, aggregation operator. And that, like I said, doesn't really make much of a difference because at the end of the day, I'm just calling the first record by way of these 2 operators at the end of the window table calc. And so what I'm doing when I use first is I'm actually copying this value and bringing it across all of these densified records to the end. And when I use last, I'm doing the opposite. I'm taking the last record and copying it back across all these densified records to the beginning. Densification is done against a binned field. So I actually have this field here, which is a bin, and then I have this Bezier value field here, which is taking my path order and just saying go from 0 to 100. And I've kept that common across all the visualizations you're going to see today, which allows me to be a little bit more dynamic in Tableau versus having to go back and modify the underlying data source as we go through. So at this point, we've created these additional records. We have 101 rows per path instead of 2. And what are we going to do with that? Why is that important to do such a thing? And that's where some of these calculations come into play. So the one I wanted to talk about first is the Bezier curve. And what I'm showing you here is actually 2 orders of the Bezier curve. On the left, you have the quadratic curve, and on the right, you have the cubic order of the curve. And the difference between those is the number of points that are needed in order to present the curve as you see it here. On the left, the quadratic curve has 1 control point, which is going to be up here somewhere. And on the right, your cubic curve actually has 2 control points, which are both going to be up here as they stand today. In this example I'm showing you, I have the control points all dynamically set based on these parameters for example purposes. So I'll run through how modifying those control points can affect the curve, which is a really important piece of my talk today in order to use these curves for all the different types of network graphs that I'm going to show. These Bezier curves that you're seeing here, I would call them almost dynamic. To have a true dynamic Bezier curve, you would have to be able to set these points via some type of math formula or calculation in order to not have to set that control point every time that you create this. So before we go into manipulating the control points, I just want to show you on the wiki page down here the different calculation equations that we're using. So you have the quadratic curve equation, which is shown here. And as you continue down, there's also the cubic curve equation, which is shown here. There's also, I think I mentioned this in Data Thursday as well, there's some really, really good visuals to help you understand how the curve works. And so with the quadratic curve, you can see start, stop, and control point. In the cubic curve, you can see the same start, stop, but here you have 2 control points. So let's start playing around with these curves and see what we can make them do. If we move the point X, which is the first control point of the 2, all the way to the left, we'll see our curve slant left. We move point 2 to the right, we'll see the cubic curve react, but not the quadratic because it only has 1 control point. Now, if we move the top point back to the right as well, they both slant left. And then if we move the second point to the left, you get this additional effect of your curve. And then obviously, when we're talking about control point X, we're moving from left to right and Y is moving up and down. As I move the control point Y down, you're going to see this curve completely flip because it only has the 1 control point. And this one looks a little bit different now due to the fact that we have 2 control points now. One's here and one's here. As we move the second control point down, you're going to see the mirrored image of what we had before. We can move the X back into the middle and vary the Y and end up with a wave looking curve like this. So just wanted to showcase basically the power of the Bezier curve and how important these control points are to the curve to reflect the type of visualization that you're going to want to see. Another item that I wanted to go over briefly is the sigmoid function. And this is one of the things that we talked about again in Data Thursday. And here's the equation down here, and here's what the curve looks like. And really at the end of the day here, we're talking about a control point at the beginning and a control point at the end. And the sigmoid function will react to wherever those points are. So as I move the point down on the left, you're going to see the curve react on the left side. And I move the point up on the right, you're going to see the curve react on the right side. And as you move these around, the curve will react, and it's all a question of math and making those points talk to each other. And so no matter where you put your 2 points, the sigmoid function will react and create this nice curve visual in between those 2 points. Really a powerful formula. Most of the information I've gotten on the sigmoid function I got from Jeffrey Schaefer's Data Plus Science site. He's got a bunch of tutorials and visuals and a lot of great content on how to implement that function in Tableau. So definitely take a look at that if you're interested in learning more on the sigmoid function. So this is all well and good, and we've made some curved lines in Tableau. One of my mentors at work, he would always answer me with, so what? What's the purpose of doing all this? Other than the fact that I think it's cool, the main benefit that I've obtained is the use of these curve functions in network graphing and really being able to limit the amount of overplotting that you may come across when looking at large networks. And so what I want to do now is go through a couple of examples that will help showcase how these curves can potentially help with that issue that you're going to come across. You can also expand on common network graphing views, also known as hairballs to some other graph types, which require things like Bezier curves to be implemented. And that's really how I got started on this to begin with. So as we go through here, I'm going to show you some applications that I found useful in my day-to-day and some that I just really find interesting. So moving on, move these over. So what you're seeing here is a viz of the day from July, and we're looking here at geospatial movement. And so you basically end up with a couple different options when talking about geospatial movement. You're going to have the exact points that you've been provided. So if, for example, if you're analyzing flight patterns, you might have every single point of the plane every 15-30 seconds, and that might be the best way to reflect the actual flight pattern. However, if you only have a start and end point, then you're really left with whether you're going to implement a straight line path or a curved line path. If you do decide to implement a curved line path, there's more than one equation you can use. In these examples that I'm going to go through today, I'm just going to be focusing on the Bezier curve, but there's also other equations like the great arc, and there's definitely been some implementations of that in Tableau. I know Robert Rouse had an arc diagram that he built where he was using some other curve equations as well. So definitely check that out. Each of these approaches has their pros and cons. While curves allow you to apply more data points onto the screen, straight lines only require 2 points instead of 100. So there is a give and take there. So like I said, here's an example of Viz of the Day from July, which featured straight line paths of refugee movements between countries. And that's what you see on the top. On the bottom, you can see a remake of that using Bezier curves instead of the straight line paths that you see on the top. And so what's the value that you're getting out of the bottom view versus the top? And really my main answer to that would just be the ability to fit more points on the screen without running into as much overplotting. You can see here on the top, we have quite a bit of dense overplotting going on in this area. And on the bottom, it's still a little bit hectic, but you can at least make out what some of the countries are that people are moving between. So one of the things I want to do to help accentuate the point is I'm going to filter on a couple specific countries and see if we can identify how the curves and the straight lines react to those. So I'm going to start with United, which is going to bring us back United States and United Kingdom. So on the left here, obviously, we have everything coming in and out of the United States, and on the right, we have the United Kingdom. You can see between the United Kingdom and Africa, we have some overplotting going on. And down here at the bottom, it's a little bit easier to determine exactly which countries in Africa the movements took place between. I'm going to do a couple more here. Sweden. So with Sweden, you see the same technique happening, where at the top you have some overplotting going on, and on the bottom you have a little bit easier way to discern the different countries that have been visited, or not visited, but people have moved to. Lastly, I'm going to do Italy. And you see the same type of situation here where you have some overplotting going on and the ability to more easily distinguish where everybody's gone to below. So what I'm discussing here is really one of the same reasons that you'll see if you ever look at like an airline flight path brochure or route map, they call them for the most part. Those pretty much always use arcs instead of lines. And the reason for that is because they have so many different routes that they're trying to fit on one view on one map. It makes it difficult to do that if you're using straight lines. And so here's a couple examples that I just grabbed off the internet. So this is Virgin America's flight path route map. And you can see, across all the different stops that they're using arcs to do that. I'm not sure exactly which equation they're using, but curves at the end of the day. And it really helps, especially with places like San Francisco and having all these destinations on the East Coast that are somewhat close to each other and being able to differentiate one location from another. And here's another one that's US Airways and American Airlines. And this one's pretty hard to read because the map in the back is too dark, but at the end of the day, you can still see that they've implemented the curved line in order to show all the different destinations that you can go to. Another, real quick on a side note, the migration data that I'm showing here, one of the thoughts that came to mind as I went about looking at this information is it would be a really interesting implementation in the chord diagram that Noah recently blogged about on Datablick. So I didn't quite have the time to implement it into that. So I was hoping to get that done, but wasn't able to. But I am looking to see how that diagram could potentially showcase the movements that we're seeing here as well. So while geospatial is an interesting way to look at this, I think that other diagram type might be pretty interesting as well. From here, we're going to go into org trees. So when you're looking at an org tree, whether it be a family tree or an org tree or any type of hierarchy that you want to be able to analyze, you can, of course, start with doing straight line paths, which is what you see here. As you're going through and doing the straight line paths, you could take a look at the sigmoid function, for example, and see if that provides you any additional benefit when looking at your data. And so in this example I'm showing you, it's not like the sigmoid function is helping you with overplotting or anything. I mean, obviously it's easier on the eyes, but I think as you continue to expand on the number of nodes and start to run into the potential issue of having too much data to fit on one screen, that's where your curve equations are going to help. One other implementation that I've done of this hierarchy type of tree is the hypertree, which I just recently tweeted about a week ago. And what this is doing is taking the base tree and basically putting it into a circle, like you see here. And one of the things that I got asked when I first built the hypertree is, what's the benefit of it? Why do we need to plot the nodes in a circle? It's easier to see them if you just look from top to bottom here. And really, I thought about that for a minute, and what I came up with was the ability to increase the amount of space that you have for your most detailed level of nodes is what I think the benefit of the hypertree is. So if you look at my sigmoid tree, you have the same amount of space horizontally for the root node as you do for all these detailed nodes down here. And obviously, as your tree grows, that's going to become more and more of an issue, because you're going to be squeezing all of these things into a limited amount of space at the bottom, and you're going to have all of this extra white space on the top that's not being used. And so it's a give and take, right? I think it's easier to follow the organization chart that's straight up and down. So if I were to just follow this path down, I think it's easier to do that on this view. But at some point, I'm going to start running out of space, and I'm going to have overplotting and issues like that. In this tree, it may be a little bit harder to kind of follow the lines because they're in a circle, and it's not as easy for us to review that just inherently. But at the end of the day, if I'm able to do that, I'll be able to fit a lot more data on one screen. So it's the old comparison of whether you put something in a circle to fit more stuff in a space, or try and keep it easy to follow from top to bottom. Another example of that I want to go through with you today of network graphing is an idea that my friend Tom Van Buskirk had a few months back. And this ended up leading us to the jump plot. And you can read up on the jump plot either on Datablick or also on jumpplot.com, which is shown here. Again, from the initial implementation of this graph type, I leveraged our trusty Bezier curve. And was able to really leverage the curve's dynamic nature, the control point I mentioned earlier. This control point that I keep going back to is really such a beautiful thing. It is what really makes the curve as powerful as it is. So here's an example of a jump plot implementation in Tableau. And what we're looking at here is an example of a procurement cycle over the last 2 years, this year on top, last year on bottom. So year over year, literally. And one of the main slogans of the jump plot is bottlenecks beware. So really the question here is, can we find any bottlenecks? And so as you're analyzing the two distributions, one on top of the other, you can see, for example, between steps 3 and 4, we have a pretty consistent delay in time. So that may be because the step between 3 and 4 takes longer, but it could also be because there's some issues in that specific process step. Also, because it's a distribution view, you can see, for example, between 2 and 3, that we've actually gotten rid of some outliers from last year. So this item here and here look to be a little bit of an outlier in respect to the rest of the data between steps 2 and 3. And on the top, you can see that those have been removed as of this year. So some of the purposes of the jump plot that you can see there. While I have a couple minutes left in the session today, I want to go through one more visual. And so what I'm going to do is base this off of a network diagram that was posted a while back on Tableau's blog around the Zen Masters Twitter networks. And so that's what you're looking at here. And so this is a network diagram. I think they built it in NodeXL, which uses an algorithm layout method. There's a couple different algorithms you could choose from, which is why I'm not saying which one they used, because I don't know. But at the end of the day, I thought it was an interesting concept to look at all the different Twitter networks of the Zen Masters and wanted to see how some of these other graph types that I've researched would apply to this. And so the first adaptation that I tried to put against this Twitter network was the biofabric, which is shown here. And I know everybody's a little surprised that I'm showing something that uses straight lines, but that is how the biofabric is generated. And so within the biofabric here, one of the things that it can add to your network view outside of the hairball is the fact that you have these triangles that show you all the different key nodes in your network. So let's say, for example, we just got a bunch of Twitter data and we didn't know that this was based off the Zens. So if you look back at this view, it would be a little bit more difficult to decipher the fact that there's about 20 different nodes in here that make up the key concept of the network. When looking at the biofabric, you'd easily be able to see that there's about 20 triangles or whatever you want to call these that make up the key network players in the network. And with the biofabric, you can see as we click on different people, you can see that it highlights their connections throughout. So you can easily see whether or not somebody is or isn't connected to somebody else. So I thought that benefit of the biofabric was pretty strong, the ability to tell what your key nodes are across your network. In the last view that I put that same network into is the Hive plot. And the Hive plot was one of the things that kind of got me started in network graphing. I just thought it was really a fascinating and fabulous way to look at networks to try and differentiate based on some dimensions that you knew of. So one of the differences between the Hive plot and the original view is that we're trying to utilize dimensions here to get greater insight into our network. And so one of the ways that I decided to split this up for this example was I put all the handles related to Tableau on the top. I put all the handles related to the Zen masters on the left axis over here. And on the right, I put all the non-Zen handles. So I'm in here somewhere. There I am. So what can we tell from this? Well, a couple things. So first and foremost, you can tell that Tableau has been in contact with all the Zens pretty regularly. And so that's visible by the fact that these lines here are actually thicker than the rest. And I actually did a size on the lines. So you can see, for example, here, Matt Lucian has 94 tweets between himself and Tableau. And so that looks to be the thickest to me. You can also see that all the Zen masters talk to each other quite a bit. So as I move up and down the Zen axis, you can see that each of the Zen masters is in contact with the rest of them quite often on Twitter. So as I just click through a couple examples here, you'll see that consistent trend across the Hive. And then the other thing that I think is pretty prevalent when looking at this type of view is just the amount of outreach that the Zen masters have in the Tableau network. So you can see, for example, if I'm looking at Jonathan Drummy, it looks like he's contacted just a vast number of people who are not Zens but active in the community as well. So I think you can really get some additional insights and interesting views on your data by using some of these alternate network graphing techniques. They all can be implemented in Tableau to your liking. One of the things I think that is really beneficial to doing such things like this in Tableau is the ability to have this interactive nature where you can highlight and filter and obviously some of these basic things that Tableau brings to you straight out of the box can be really powerful when looking at networks, especially ones of greater size, because it can be really difficult to view your whole network at one time in a static screen. So I think at this point, I got to figure out what I'm going to do next, and it's probably going to be something around the lines of trying to finish that dynamic nature of the Bezier curve. But we'll have that coming in the future, hopefully. And with that, I'll go ahead and give it back to Emily to see if we have any other Q&A or anything like that.
Thanks, Chris. So lots of great comments on the questions and answers panel. There's one question that Catherine wrote in, which she's super excited, which I like that, Catherine, about the jump plot. Are you planning on any content around how to get real world data into the shape you're using in these vizzes? 2 rows for each event. She's been struggling with it. And unfortunately, that's the only question we're going to have time to answer, but certainly take this conversation on Twitter or blog, it's because it's a great one.
Sure. And if you want to contact me on Twitter, my handle is @dmartsc. You'll be able to see me on there, and feel free to ping me with questions. I'm happy to answer those. With respect to getting the data prepped into that view that I showed earlier, the way I've done that for the most part is when using SQL. So I use SQL Server as a backend a lot at work. And so my main skill set with respect to data preparation is in SQL. I think other tools out there like Alteryx, I've heard really good things about Alteryx, and I'm just kind of starting to get into it, but it seems really powerful to me and would be able to benefit with getting the data into that structure. But at the end of the day, you're going to take a relationship between 2 points, and whether it be on the same line from where you start, or maybe you have several lines and you got to boil them down to 2 lines. It's just a question of filtering and manipulating that to get it into that two record format to start. And that's really the beginning of everything you saw in the presentation today.
All right. Well, Chris, thank you so much. This was great, and I'm excited about the jump plot. I immediately thought of a use case for it. So
Okay.
I really appreciate you taking the time. And let's see, at 12:30 East Coast time, we'll have Alex Duke talk about minor tweaks for a major response. See you then.